Hi everyone, my name is Ray Banting Flores and welcome back to my YouTube channel. For today, we will be discussing one of the application of integration with this topic of area of a surface of revolution. So at the end of this video, the learner should be able to solve for the surface area of a revolution using the process of integration. Before we proceed to presenting some examples, let us be familiar with the surface of revolution. So, it is formed when a curve is rotated about a line. So we all know that we have two lines in the Cartesian plane. We have the x-axis and the y-axis. Proceed, we have this such a surface is the lateral boundary of a solid of revolution. So we will be enlightened more as we proceed to the preceding slides with regards to this definition. In solving for the surface area of our revolution, we will be considering two lines as what I have said, where if it is rotated or rotating. Therefore, we have two lines, but in the two specific lines, we have two formulas to consider. So all in all, we have four formulas to be familiar of. First is we have the formula of if it is rotating about y-axis, we have this given function. If it is in the looks like in this given example function, we have y is equal to the f of x as a is less than or equal to x, but x is less than or equal to b. We have this surface area, which is equal to the integral of 2 pi x square root of 1 plus the dy over dx squared dx evaluated from a to b. So the second formula for the if it is rotating in the y-axis, if it is the given function look like if x is equal to the g of y, where c is less than or equal to y, but y is less than or equal to d. So we have this given surface area formula. The integral of 2 pi of gy, the square root of 1, plus the dx over the dy squared dy evaluated from C to D. So as you observe, the difference between the two, the first formula and the second formula is the variable we use to denote the limits, which is from A to B became C to D in the second formula. However, we have also difference here. The first formula is the dy over dx squared dx. However, in the second formula, we have dx over dy squared dy. So just be cautious with that difference. Next is for the if it is rotating about the x-axis and the given function is y is equal to the f of x as a is less than or equal to x, but x is less than or equal to b. So we have this surface area formula. So we have the integral of 2 pi f of x, the function of 1 plus dy over dx squared dx evaluated from a to b. So it is just similar to the first given formula of if it is y-axis. So the second one is rotating about the x-axis again, and it is if the given function x is equal to the g of y, c is less than or equal to y, but less than or equal to d. So this is the surface area formula, which is similar also to the second formula of the y-axis. But the sense of presenting this four formula is that to consider the four or the changes and where the graph or the surface area is rotating. So let's proceed with this formula of the integration of 2 pi of y square root of 1 plus the dx over the dy squared dy evaluated from C to D. So let us now apply one of the formulas in this example number 1. which is we have this, find the area of the surface obtained by rotating the curve. So the function of that curve is y is equal the square root of 4 minus x squared. And the limits is -1 and +1. And it is rotating in x-axis. So, since it is rotating about x-axis and the function looks like this, so we will be using this given formula of the integral of 2 pi of f of x square root of 1 plus the dy over the dx squared dx evaluated from a to b. Again, this is our given, and this is our formula. So we will be in solving this and to make it more easy, let us first find the dy over dx of the given function, which is here we have function the square root of 4 minus x squared. So we could write that in this form. The square root of, from the square root of 4 minus x squared, it is also can be written in 4 minus x squared raised to the power of 1/2, since square root is equivalent to 1/2. From that, to find the derivative of that, we have this x squared, no, negative x rather, over the square root of 4 minus x squared. And since, as you observe here in the given formula, we have this squared, so we need to square this derivation. So we have this and be equal to the x squared over 4 minus x squared. And by that, we are now able to plug those values. So we have this formula, the surface area formula, but is equal to the integral of 2 pi, since it is given, the function of x and the square root of 1 plus x squared all over 4 minus x squared as the value of the dy over the dx squared dx, evaluated from the -1 to +1. So proceed. As you observe, we have this value that we just simply, we have the passive addition symbol here, and as you remember, 4 minus x squared is the value of the square root of 4 minus x squared is the value of f of x. We just simply substitute it to 1 plus this, the dy over dx squared. We just simply distribute, so we came up with the integration of 2 pi the square root of 4 minus x squared times 1 plus 4 minus x squared multiplied to x squared over 4 minus x squared dx. To solve that, we all know that we have this denominator here 1, so we just simply cancel out this, and then we all know that 4 minus x squared times 1 is simply 4 minus x squared. And the remaining value here, which is x squared also, plus x squared. So that the negative x squared plus x squared will be eliminated. So we have now the surface area of, which is equal to the 2 pi, since it is given, we just excluded it from the integration. 2 pi, the integral of the square root of 4 minus square root of 4 dx evaluated from -1 to +1. So we all know that the square root of 4 is equal to 2, and then we integrate that, so we came up with as the surface area, which is equal to 2 pi multiplied to 2x, evaluated from -1 to 1. We just combine and we exclude 4 pi and then substitute the value of 1, -1 and 1 to the variable of x. We came up this. The 1 minus -1 is, since it is both positive and negative, so it will become positive. So 1 plus 1 is equal to 2. So we came up with the surface area value of 8 pi. So this is the example number 2, and it is your task to try. Find the area if the surface obtained by rotating the curve. So this is the function of the curve, which is y is equal to x cubed, and then the limits of 0 and to positive 2, and it is rotating in x-axis. That will be all. Thank you and good bless. Bye bye.